Now we will start in next 2 minutes, right?
Okay. समीर वो वेटिंग
Hi,
रूम
Swati.
मैसेज आ रहा है. Should I put admit all?
Hi, Swati. Can you hear me?
Yes.
Okay.
Sameer, how to make admit all? I'm keeping messages I'm admitting. How do you make admit all?
Madam, as and when people enter, then and then we able to admit all.
Okay,
If
I'll
not,
do it. I'll do it. Okay.
Hi, Yashwant.
Hi.
Whose voice is this? Can't see you on the screen.
Yeah, who is that? Everybody
Sounds like
seems to be on,
Satish Tibira's voice, but I can't see him.
everybody seems to be on mute.
No, your video is off.
My video I put off.
I want you to put it on.
Welcome Jayan Joshi, Jagdish Chinappa, Neil, Dr. Grade Annas, Avinash Kenikar, Jay Mani.
Good evening, Swati. Good evening. You're, as usual, looking as distinguished as ever.
Thank you. Thank you.
Hello, Yashwant. Namaskar.
Hi, Jagdish. क्या म्हणतोय?
Maje mein, how are you?
We are
You're
recorded,
being truly like a professor. Truly like a professor.
but we are being recorded. These are recorded now.
It doesn't matter. I'm only saying good things.
No, that means you should say some profanity. This is being recorded for posterity.
We have our chairman of our international forum, Dr. Grade Annis. Welcome, Dr. Grade Annis.
Yeah.
Hi there, I'm here. Greetings from
Hi.
USA.
Hi. Welcome, Dr. Kenikar. She's
I'll
HOD
unmute myself.
Sussu, Pediatrics.
Thank you, ma'am.
Sameer, whenever you want to start, you can start. You want to wait for 5 minutes more?
No, ma'am.
Let's start.
It's a 8:05, so we are starting now.
Okay, start.
Right. So, dear friends, very good evening. In today's one more session of the AACCI International Forum webinar series, and in a series and in the row, this is a seventh in a row our presentation, and this will be today is the one of the unique presentation by our two renowned speaker on the artificial intelligence. But before we start today's presentation, with a grief, we have to take a 2 minute silence for the our own beloved founder member, Dr. Sujata Kanere. She just passed away very recently on the 28th July, and for that purpose, we are starting the our this today's webinar debut to her, and we can having a 1 minute silence, and then we will start our today's presentation. Om Shanti. So to give the homage to our beloved madam, I requesting our Executive Director Dr. Swati Gave ma'am to start this her speech related to that.
Today is the first Today is the first AACCI webinar after the untimely and sad demise of my very, very dear friend, Dr. Sujata Kanere. She was more than a friend, she was like my younger sister, and my whole family was very close to her. Today, we are having this very short homage, but we have planned a special dedicated webinar to Sujata in the month of November, where we plan to invite her family to share the inspiring journey which she had. We'll also be announcing it to the all AACCI volunteers, those who would like to speak about her and also share whatever photos they may have in their old albums. So today is just a short homage to my dear friend, and we'll have a full webinar later. I am very thankful that Sujata's family, Mr. Vishnu Kanere, who's a husband and a chartered accountant, and Dr. Gayatri, who's also now joining to be a chartered accountant, have present here. And I welcome them on their behalf, and we will be definitely connecting with them for the big webinar. Mr. Kanere, would you like to say a few words?
Thank you. This evening, when I heard the names, like you and sir, of course I know, but many of the other names are known to me. I have heard them, although I have not seen them. Like Kinikar ma'am is there, so many. Surekha Joshi ma'am is there. So I remember them. We acknowledge your kind remembrance and condolences by maintaining that 1 minute silence for Sujata. We are deeply touched by your very kind gesture of planning to hold a meeting sometime in November in or wherever it is convenient. So essentially, it will give us an opportunity to interact with AACCI members because she was quite close to some of the AACCI members and she was very active in the association, even when her health was not up to the mark. Just one thing I'll wish to say that yes, it will be a meeting for remembrance, but the way her nature was, she was so happy that even when she passed away, she was smiling. Her last words she spoke to everyone, and she said, "Be happy," and she smiled at everyone and says, "I'm going home." So that is something, and she thanked all the doctors. She thanked the sisters for taking good care of her. So she did not forget to be calm, composed, and happy. So all those days when she was in the ICU, she was even speaking to people. She was writing on the iPad and communicating to all of us. And whoever came, I mean, when the doctors asked every time, they used to come on the rounds and ask, "How are you?" She says, "I'm good. Can't you see?" And she used to give her radiant smile. So uh, let us remember her. It would be a celebration of remembrance. Thank you so much.
Thank you, Vishnu. We really want to have that webinar dedicated to her, and her journey and the way she struggled with a chronic debilitating illness will be inspiring to many of us who are also suffering chronic illnesses. Thank you so much.
Yes, thank you.
Now I request our chairman, Mr. Yashwant Bhave, to welcome today's speakers and welcome Dr. Gredanis, and then Samir will take over for starting the program.
Yeah. With your permission, we'll
Yes.
log off.
Thank you so much for coming. Really appreciate it. Thank you.
Thank you, Mr. Kanere. Good evening, everybody. I am indeed very happy and proud to welcome all of you to this seminar on understanding AI, potential, benefits, and risks. This is a part of the AACCI International Forum webinar series. I also welcome the panelists, especially Dr. Gredanis, also as the chairman of our International Forum. These panelists will be later introduced after me by Dr. Samir Shah. AI has already pervaded our lives, most of the time silently. and perhaps also insidious. It is a kind of animal difficult to describe, grasp. It is so multifaceted. Whenever one feels that he or she has obtained some kind of grip or insight on AI, it certainly changes its structure. There is a theory which states that if ever anyone discovers exactly what AI is for and why it is here, it will instantly disappear and be replaced by something even more bizarre and inexplicable. There is another theory which states that this has already happened. The panelists thus will guide us today evening through the intricacies of this new technology that is both disruptive and, unlike other ones, can also be intrusive. Thank you all. Thank you very much. Over to you, Samir.
Thank you, sir, and thank you, madam, for the starting the ball roll. And my welcome to each and every participants of today's webinar in very one of the important topic that we all want to know more and more, because it's a very new topic, that is about the artificial intelligence. And for that, today we having a two eminent speaker. So let's I just start my presentation related to that. Before I start the about the artificial intelligence, let's see a one short, very short video we all know about, and many of you able to see that video in very well in the
Looking to
front.
upskill for the future?
This new AI can perform all coding jobs in seconds, including blockchain development. While this AI is already outperforming accounting firms. Meanwhile, the new graphic design AI aims to automate graphic design and could minimize the need.
Relax. Because in a future where AI does most of the work, there'll be one thing that humans will finally get to do all day long. Nothing.
So, dear friends, artificial intelligence is a fast evolving field and having a very potential revolutionize the way what we live. And this is a world of the information access rather than the scarcity. And with the new technology and it evolved, it will be associated with the so many terminologies and the jargons that we have to understand. Same is true for the understanding the artificial intelligence, how it is potential, what are the different benefits, what are the risks, and how it will be hallucinate our regular day-to-day life, that we have to understand. There are so many facets of the artificial intelligence bombarded in our day-to-day life also. We have so many webinars and so many series on the YouTube. You can see that artificial intelligence do so much thing in it will be the changing the our life. It may replace the human being. That type of the scarcity is there, and let's see how it would be actual is. And for that purpose, I just happy to introduce our first speaker, Dr. Aruna Joshi. She is PhD and FRM, and at presently she is working as a vice president in the model risk management at Visa Inc. She was the former SVP model risk management at Bank of the West San Francisco, also the VP in the Model Risk Management at the Wells Fargo Bank, San Francisco, and VP of the Model Risk Management at Union Bank also. She was the Director of the Risk Modeling and PMI Mortgage Insurance at Walnut Creek from the CA. So she is one of the our first speaker, and the second speaker will be Dr. Ajinkya Vaibhave. He is PhD in the systematic and control in MS in robotic and MS in ECE from the Carnegie Mellon University, USA. At present, the director at the Sim Center Engineering Service and head of the India STS COE at the Siemens Digital Industry Software. He is the part of the advisory committee of integrating artificial intelligence for the strategic application across the digital industry software. Recipient of the Siemens STS Innovation Award in 2019 for his contribution to innovation in machine learning across the multiple applications. He was the research faculty at the Carnegie Mellon a founding member of the Robotic Research Center at IIT Hyderabad, and recipient of the NASA Group Achievement Award for the Spaceward Bound 2006 expedition in Chile. So, you know how they are. Our speakers are. Both is very passionate to learn about the artificial intelligence, and also they are the masters in their own field related with the artificial intelligence. So let's start with our first speaker, Dr. Aruna Joshi, to demystifying the artificial intelligence versus the machine learning. So, madam, this stage is of yours. I am stopping my sharing.
Okay. Okay. Thank you very much. Good morning, good evening to most of you. I'm really honored and very excited to share about artificial intelligence. This, it's basically, it's a topic that is near and dear to my heart. And that's what I do at Visa, actually. So let me start sharing my screen. All right. So let's start with, what exactly do we mean by AI? As all of us know.
Madam, can you do the slide share, full slide share?
Okay. Yeah. Okay.
Perfect.
Okay. So what exactly do we mean by AI? Well, all of us know AI stands for artificial intelligence. It's a field which is part of computer science, and artificial intelligence basically means the science of making intelligent machines to think, reason, and learn. Believe it or not, this field actually started in the 1950s, but because the computational power was not that high, the field kind of languished for a little while. In about the 1980s, something called machine learning started to flourish. What do we mean by machine learning? It's basically giving the machine the ability to learn without being explicitly programmed. And just to give you an example, the simplest machine learning model that all of you must have used at some point or another is just a linear regression equation. So you have some data, you see that it has like a linear trend, you fit a line through it. When you get a new data point, you can fit that into that equation and you get your answer. So that's the simplest machine learning algorithm. Then in the 2010s or so, deep learning started to evolve. And deep learning is basically a class of machine learning models that is inspired by artificial neural networks. They're again inspired by the human brain's use of synaptic connections. And of course, most of the doctors on this call know much more about it than I do. All I know is how these artificial neural networks help in solving some of our problems. So let's look at some of the classic AI failures that we have actually encountered. So some of them are, not so harmful. Some of them can be pretty harmful. So the first one, which kind of was intriguing, was when the iPhone 10 introduced a Face ID to actually unlock your phone. Some people figured out that it could be fooled with a 3D printed mask. And there was actually, some kind of an AI that was using image recognition, and it really failed. The other tool that can be kind of harmful, considered to be harmful, is Amazon had come up with an AI recruiting tool that showed some bias against women. And I'll go into a little bit more detail about that example. Another one on the bottom right was when Microsoft had come up with an AI chatbot. Chatbot is basically, just an interaction with a machine where a user asks questions and the machine will give answers. And this chatbot was actually learning as the questions were thrown at the chatbot. And it actually became extremely racist within a day. And Microsoft actually had to shut it down. And the last one, which is a little funny, is there was an AI camera operator, and it was supposed to follow a soccer ball during a game. And then the camera got a little confused because the referee of that game was actually bald. So the camera actually started following the referee who was bald. So it was kind of a benign example, but you can see what failures were caused.
வாங்கியிருக்கேன் உனக்கு வாங்கி கொடுத்தேன்.
All right. So let's look at why AI is experiencing such a huge boom. So as we all know, the data is getting bigger, smarter, more affordable. There is copious amounts of data. Facebook is collecting, Google is of course collecting. The computing power is also getting much more higher, and the algorithms have become much more accurate. And by algorithm, what I mean is just the way to process the data from some kind of an input data into an output. And if you look at the graph on the right side, you'll see that the gray line, it shows the storage units. So it went from 2010, it went from about, close to zero, well, higher than zero, but it's more than 3 zettabytes of data. Zettabytes is even bigger than terabytes. And in terms of the giga floating point operations, you can see that the cost has gone down also by a lot. So these are the two things that are really driving the AI boom. So before we actually go into, what does AI do and whatnot, I'll just go into the basics of AI models. So what do we mean by a model? Well, model is just a representation of a real world. So what you do is you have some inputs. It can be variables such as, any kind of data. For medical terms, it could be patient's history, etc. You have a processing component, and it can be an algorithm, which is like a neural network or logistic regression, things like that. And then you come up with an output. And the output is actually used to make decisions. In this particular context that I'm showing is to make business decisions for a company such as Visa. So that's basically what a model does. Now, because the model is a representation of a real world, and there are lots of assumptions made in a model, there are lots of risks associated with that as well. So before I jump into the risks, let me talk about some types of machine learning models that we encounter. One is called the supervised learning, which is over here. And here what we do is we are trying to train a machine using certain kind of data where you have some known data. And a simple example here is you have a bunch of images that look like apples, and you have certain characteristics. And then for each part of the data, you give a response as well. So if you have an apple, you say it's an apple. If you have a banana, you say it's not an apple, things like that. So that's the kind of data that actually goes into your model. And then you train the model on that data. And then when some new data goes in, the machine is able to predict whether that thing is an apple or not. So this is called supervised learning because it's some kind of a training scenario as a teacher teaching what's happening. And the example in terms of the medical terms is the mortality probability model, which is a clinical scoring model to estimate the mortality risk based on the patient condition, admission type, things like that. It's one of the most common applications of machine learning. The second one is unsupervised learning, where you put in a bunch of input data like apples, bananas, mangoes, whatnot, and then you teach the algorithm to actually separate them into different categories. And the example here is, if you want to do a phenotype clustering in healthcare, you give some inputs like clinical data, biomarker values, genomic data, etc. And you do some clustering, and then you can figure out some unique groups, and then you can make your decisions based on that. And the last type of machine learning models is called reinforcement learning, where you give an input to a machine, the machine makes a guess, and then you provide a feedback to the machine. So in this case, you put in an apple, the machine says it's a mango, and then you give a feedback, no, it's actually an apple. And then the machine learns like that. And then later, when you give it an input, it actually can come up with the right output. And the example of this is the self-driving cars. The most common type, as I mentioned, is the classification model. I will not spend too much time in this, but I think what happens here is, this is just an example of, let's say, some loan applicants have applied for a loan. Banks typically will use a classifier model and categorize them into how likely are they to default or not. And this is, again, a very common application in epidemiology, in medicine, etc., where you're trying to categorize, the patient's health. You're trying to figure out, the survival probability, etc. And these are some of the common metrics that are used to see how good your model is. So as I mentioned, all the models, all these machine learning models or artificial intelligence models, they're actually taking in some data and they're processing them and coming up with an output. But there are lots of risks associated with this data as well. The first risk is the data is not really representative of the population. So an example is someone builds a great model and it takes all these heart attack symptoms. And let's say the model is built only on the symptoms that men usually experience for heart attacks. You would take, sweating, pain in chest, etc., and you build a wonderful model. But someone may say that, oh, you have a great model for heart attack probability. Let me just apply it to the full population. But then you will see that women actually may experience very different type of symptoms. And that model is going to fail because the data that you have used, that is just the men's health, is not really representative of the whole population. Similarly, this is another example where you may have some biased data due to missing values, etc. So a simple example is someone is trying to come up with a model to recognize images of shoes, and they've only trained it on athletic shoes. And then someone puts in a high heel shoe and the model will say, oh, it's not a shoe. So you get the point. The next is the model, next risk is related to theory. So typically what happens is you start with a full data set, then you split it into training and testing. You train your model on this training data set, and then you test it on the remaining. Now, in terms of theory, the different types of risks that can arise is either you're using an incorrect or an inappropriate theory. And on purpose, I put in an equation here, which is supposed to be the roots of a quadratic equation. And as you can see, instead of b squared, somebody has put b cubed. And of course, this is an incorrect theory. Similarly, someone may put different types of independent variables that have no real causation to the problem you're trying to solve. And this is a classic example where people say that, or someone got some data which showed that the ice cream sales are actually proportional to the shark attacks. And this may be true on a beach in Florida, let's say, about the ice cream sales in the summer, but obviously you can see that you cannot generalize this. So this is another model risk that can arise from models. And the third one is outcomes analysis. So you may think you have used a great theory, you have wonderful data, but how does the model actually perform in real life? And this is a small example I've given, that you have a model that fits really well. You've trained it on, let's say, this part of the curve. The model looks really, really good. But as soon as you come across some extremely rare events, the model starts to fail. Similarly here, your model is performing really well on that training data, the in sample. And as soon as the model encounters some data it has never seen before, it starts to fail. This is kind of similar to, and hopefully doctors on this group will appreciate this joke. So a colleague is telling him, oh my gosh, your surgery was brilliant, well done, but too bad the patient died. So outcomes really, really matter. Now let's switch gears a little bit and talk about, why is AI becoming so concerning and scary, etc. So let's first try to get a distinction between fairness versus bias. Fairness is the property of being fair or equitable versus equal. And this figure that I show here, it actually demonstrates the difference between equality and equity. So what is happening here is, there are three individuals with different heights. They've been given absolutely equal treatment by giving them stools to stand on. And as you can see, the person who's the shortest, even though he has a stool to stand on, is not able to look over the fence to see what's happening. Whereas in equity, what we do is we want to provide opportunities so that the outcomes are sort of equal. So here you actually give 2 blocks to this individual, so he can also see over the fence. And this guy is okay with 1 block, and this guy doesn't need anything at all. So that's the difference between equality and equity and how you want to make your model fair. On the other hand, bias is the inclination towards something. That means there is some kind of partiality or preference, etc. And the bias can be different types. You can have some ethical bias. In this case, it's actually intentional, good to have, so that you have a good outcome, such as in this case. Whereas you can also have bias that is unethical, where you're purposely creating a situation which is coming out with an outcome that is unethical. And in the US, actually, a lot of times what was happening is some of the minority communities were actually being denied loan applications or credit applications. And there was a lot of bias around that. So that would be an example of unethical bias. So how does the bias actually creep into the model? So as I mentioned, you start with some kind of data, and sometimes the data is in such copious amounts that you have to actually take a sample of that data, create your data set, split it into training and testing. Then you build your model, and then you deploy it in the real world. And this graph actually shows different stages where bias can actually creep in. So there is historical representation, etc. So I'll actually go through some of quick examples of how the historical bias representation, etc., could creep into a model when you're building it. So historical data, basically, if you're taking some data, but it no longer reflects current reality, you could have a bias in the model. And going back to the example of Amazon creating that recruiting tool, so what happened was Amazon used all the resumes that were submitted over the past 10 years, and most of the applicants were men. So it actually tried to favor men over women. So for example, if it saw something saying that, I headed the women's group or something, it was actually giving that particular feature less importance. So as a result, what was happening is, because of the bias in the historical data, the outcome of the model was also biased, which was favoring men. And I love this cartoon as well, because the dad is asking the son, hey, why did you flunk history? And the son is saying, the teacher asked me about stuff that happened before I was born. So basically, you need to pay attention to what kind of historical data you're working with. And this is another example, and I won't really go through this. It's related to, again, some medical care, which was being given to whites and blacks. And they wanted to see, who is actually likely to be sicker. And because of the historical bias, the blacks were actually, who were actually significantly sicker, were getting the same score as the white patients, because the white patients go to the doctors much more. Now let's go to the representation bias. So this happens if the model is trained on a data set that is not sufficiently representative of the population. And I went through this a little bit, saying that you start with a huge amount of data, then you take a sample of the data, then you build the model. So if your sample itself is biased, your model is going to be biased as well. So the examples here are you target a population for modeling an infectious disease, and it might be all adults, but the only medical data that may be available is the sample of people who are actually serious enough to bring in for further screening, because with mild symptoms, people are not likely to go to the doctors. So if you build a model that predicts infectious disease, but you don't even have the data of people with mild symptoms, your model may be really off. The other example is that of a jury. Now, this is not really applicable in India because I don't think the final verdict is given by a jury. But here in the US, as you know, it's a racially very diverse population. So when you have a jury, you want to make sure that your jury is made of your peers who can understand much more. So it's basically representing you as well. And a quick example of measurement bias. So this is basically you're choosing, collecting, or computing features. Features are those input variables that go in, and labels are in that supervised learning. If you saw a picture was apple, and then you have a response which says this is an apple, so that's called a label. And in this particular case, you use features and labels that are not directly observable. And this is another example where there was a model that was built to figure out whether a defendant would become a repeat offender. And some of the features that depict were previous arrests, age, employment, and the output was a risk score for someone who's likely to repeat that offense. And the bias that crept in here was minority communities are much more highly policed. Black defendants were incorrectly labeled as high risk to commit a future crime twice as often as their white counterparts. So basically, the model predicted twice as many false positives just because of this measurement bias that occurred. And then this is another thing that you need to pay attention to. It's the deployment bias. So basically, if there is a mismatch between the problem that a model is intending to solve versus the way in which it is actually being used. And this happens when you build like a fully autonomous, but it operates in a very complicated situation. Is there a question? Sorry. Okay. And this is a very funny application, actually, just to bring this idea across. So during COVID, there were masks being distributed, and people just associated a mask with prevention of a disease. So this guy is talking to him. He's saying, oh, I've been vaccinated. We are outdoors. My risk of infection is next to zero. So why are you wearing the mask? But the purpose of a mask out here, who's a robber, he's using it to hide his identity. So the model was the mask being used for protecting you against the disease, but it's actually being deployed in a completely different way. So this is another example where a model can fail. Now, let me quickly switch gears and talk about our, most of the models these days that people are coming across is ChatGPT or Google Gemini, etc. So those are the models that are using large amounts of text, and they're actually creating content, etc. So this is called the large language model. So it can recognize, generate text, etc. And the examples of large language models are your ChatGPT, Google Gemini, etc. And recently there have been news articles on issues with Gen AI, etc. And actually Ajinkya is going to go into more details about the errors or the big problems that generative AI, these are called the generative AI type of models, as opposed to predictive AI, which was trying to calculate probability of a default or mortality risk, things like that. So you're trying to predict something, whereas in generative AI, you're actually generate something, generate a content, things like that. And these are some of the problems that were encountered. with generative AI. The most popular use cases are, of course, summarization, where you have a large amount of text or documents or emails, and you just ask ChatGPT or Google Gemini saying that, hey, just summarize this for me. So that's the most popular case. Content generation, and a lot of you may have toyed with ChatGPT, where you just say that, oh, can you write me a limerick on how ChatGPT is taking over the world? And it'll create a really, really excellent limerick for you. So that's called the general content generation. And again, the examples are the chatbots, which are ChatGPT, Google Gemini, etc. So these are all the chatbots, and more and more are being released. Almost every company is releasing a chatbot that is somehow using either ChatGPT behind it or Google or something like that. And the last use case is that of sentiment analysis, where it uses large amounts of data, and it can actually distinguish between the sentiment, meaning reading the passages, it can figure out whether it's a positive or a negative sentiment. And similar to the other model risks, we also have a lot of concerns related to generative AI. And I won't go into much more detail, but you want to make sure that the model is working correctly. Is it giving the right answers? And that's where you may have heard the term hallucination, that the model is actually making up some content. This happens with generative AI quite a lot. And then again, similar things like, is the model fair? Is somebody accountable? There are some privacy concerns that Ajinkya will talk about. And then finally, does the end user know that they're actually getting information from AI models? So a lot of companies are paying attention to these 5 things, and they are building or they're deploying AI based on these principles. So that actually is the end of my presentation. And Ajinkya will go into much more detail about how exactly AI is likely to affect our future. So I'll stop sharing, and thanks very much. And over to you, Ajinkya.
So thank you, madam, for your excellent presentation about how the AI can bias ourselves, and definitely many questions will be there in the mind of our delegate, and we will take that at the end of our next presentation. Before the Dr. Ajinkya start his presentation, I requesting every participant who having any query related with today's presentation of Dr. Aruna Joshi, or any questions related to the AI, you can ask into the chat box, so we can take it in the end of our presentations. Yes, it's over to Dr. Ajinkya.
Yeah, thank you, Dr. Shah. Let me start sharing my screen. Okay, I assume all of you can see my screen.
Yes.
All right. Well, namaskar.
Make a full screen. Yeah.
Oh. It should be full screen. So namaskar and good evening, good morning to all of you working across the globe, I guess, both India and out of India. So as Dr. Joshi said, my presentation will be more focused on generative AI, not the classical AI. And for the simple reason that in today's world, the generative AI is picking up a lot. So a lot of the new advances, including the new applications, are being fueled by this. So this presentation will walk you through one more way of looking at AI. So instead of artificial intelligence, we're talking about augmenting intelligence. And as we go through the slides, you will understand what we're augmenting and what kind of intelligence we're augmenting. So the agenda and the flow of the slides will be fixed on these 4 topics. So when you talk about AI today, you'll see that people typically fall on 2 ends of a spectrum. There are those who believe that AI is the next big thing that's come up. It's the next electricity, the next quantum mechanics. It's going to change the way the humans interact, the world works, and so on. So that's one set of people who believe AI is positive, it's for good, and there's a lot of hype around that. So that's one part. But there's a second set of people who are on the other end of the spectrum, who talk about the fact that AI can take over jobs, AI can destroy social structure, AI can lead to nuclear holocaust. And that's where the fear factor comes. And as in all human emotions, the reality lies somewhere in between. So we'll talk about where AI is today in the reality section. And then given this, how do we coexist? What's the balance? That's the last section of this presentation. So when you talk about the hype, this curve is called the Gartner curve. They take out this curve every few years in terms of, for technology, where is it in terms of the people's expectations? So on the left y-axis, you'll see the expectations from people, the general public, from practitioners. And on the x-axis, you'll see time. And the typical way all technologies develop is that first there's a lot of innovation because it's a new technology, people are seeing applications. And so the innovation triggers is a rapidly exponentially rising curve where the technology is gaining more and more traction, both in terms of maturity and acceptance. And it reaches then a peak called the peak of inflated expectations, where people are expecting a lot of things from this technology. And that's typically always, before a fall. So from the expectations, the technology may or may not live up to the hype. And so then it falls into this lesser expectations called the trough of disillusionment, where people have sort of understood that the promise doesn't live up and they're trying to see what to do. And from there, you go to the slope of enlightenment, which means you start using technology in the way that it actually is commensurate with the capability. And finally, you'll reach what's known as a plateau of productivity, where you're using it in day-to-day life, industrializing it, using it as part of your activities. So this curve it's representative of most technologies. And you'll see, for example, autonomous vehicles, which I work on quite a bit. It's now reached a place of disillusionment because there's been 10, 15 years of research, and we're still not at the place of robotaxis. Now, you see here generative AI, for example, which is the focus of this talk. It's right now at a peak. It's at a place where people are really expecting a lot from it, sometimes rightly so, sometimes not. So generative AI foundation models, of which ChatGPT is one, and the idea of AGI, artificial general intelligence. These are things which are gaining traction, a lot of startups who have investments, but there is going to be a hype, and we'll see where that comes from. Okay. And you see that, especially for AGI, there's a 10-year horizon where it will be mature enough to be used. That's what Gartner claims, but there are others who don't think so. So part of the hype in the next slide is the idea of AGI. So people ask, what is the difference between AI and AGI? And frankly, the answer is not much. AGI was a term coined because AI, the technology behind AI, rapidly grew to the point where it surpassed all the tests that humans made, which called something intelligent. So if you remember Deep Blue, or when Gary Kasparov was beaten by a deep search machine, people in the past thought, chess is the epitome of human intelligence. If you can make a machine that can actually beat a human at chess, that's intelligence. But when it was actually beaten with brute force, depth first search, and combined with heuristics, people then shifted the goalpost. So, chess is still structured, chess has rules, it's not really intelligence. Let's go further. So what happens is every time AI comes up to the acceptance test for what it means to be intelligence, humans shift the goalpost. So AGI is just AI in a general sense, because we can't accept yet that AI has beaten us in many, many places which were considered intelligent, right? So we have to coin a new term called AGI. AI just beat us in Go, which is a very complex game, but now it's one more bar. So if you see here, these are quotations from different people who are considered at the forefront of AI research and AI impact. All of them have predictions in different ways. So Ray Kurzweil, who's an AI futurist, he's written many novels which actually predict the coming of the age of intelligent machines and then spiritual machines, where AI can actually think for itself. He's very, very optimistic. He talks about the AGI coming by 2029, basically 5 years from now. And he says from his point of view that actually I'm being conservative. People think it can happen next year, right? So that's one viewpoint. The other viewpoint is from Jensen Huang, who is the CEO of NVIDIA, which is the company that makes primarily all the hardware and the GPUs that is driving the deep learning and AI boom in terms of cloud computing and rapid hardware computing. So he says something similar to what I just said, that if you give AI a test, which we can think about as intelligence, and you give it to a computer science team and the industry, within 5 years, they will come up with algorithms to beat or come up to level with that test. So even he's talking about a 5-year prediction horizon for rapidly increasing intelligence for machines. And then we have Jan LeCun, who is the director of AI research at Facebook, well, now Meta. And he's a little bit more conservative. He says that AGI doesn't happen with a flick of a switch. You actually is going to have incremental progress where small advances will reach to a point where there comes a singularity in the future. And these are all very valid views from people who've worked in this field for decades. There's no one right view because it's very difficult to predict the future. But the point being that the hype, the expectation is that we will have intelligent machines, human level intelligence, and potentially beyond within a very short time. And that's what people are hoping for from intelligence from AI, right? A lot of it fueled by generative AI. But then we go to the other end of the pendulum, which is the fear. And this is true across all backgrounds, all job profiles. I'm just giving you 2 examples here. One is in the area of anime. So the Japanese animation industry is very, very focused on human level anime because they're very artistic, they're creative. But for the first time, Netflix created an animation film which actually used AI as one of the creators. So you see for the first time here, the background director and the background designer is an AI algorithm, a generative AI algorithm to create these backgrounds that you see on the left-hand side, where the human had to then fill in a little bit of the details. So this is something that has happened. It's pathbreaking because the film is actually released now. It's called The Dog and the Boy. It's a very nice film. You can go and see it. It's about 5 or 10 minutes or so. But what caught people's attention and therefore the ensuing backlash was that AI was used in a place where typically humans were the rightful owners, right? And the reason there was a backlash was because anime artists in Japan are paid very poorly. And there was already job loss even before AI came in. So now when you have AI taking over human jobs, creative human jobs, there's a lot of fear and a lot of anger against the fact that you're automating things which are traditionally human, traditionally our creation. That's one example. And you can extrapolate that to the medical industry, radiology, expert systems for doctors, and so on. So there's a very real fear that AI will take over human creativity and human jobs. The other place where AI is taking over is in my field, software field, where very recently there was an AI software engineer called Devin. The company was called Cognition Labs. It's a well-funded AI startup. And the details aren't important on the slide, but what the creator is asking Devin to do is basically create a software program from scratch, just asking a few questions. So Scott, who's the designer, is asking Devin to create a software program which can actually do testing of certain protocols, right? And then Devin actually has the ability to understand the language using a large language model, and then go through and create a detailed plan, even looking up resources on the internet, looking up documentation for the different APIs, and so on. So he's created a detailed plan, just like a human would, and then he actually executes. And I'm saying he because I'm anthropomorphizing the software agent, but it's Devin. And what you see is that the score from Devin, so this is a benchmark that's used for how to solve software engineering problems, right? The SWE benchmark. And what's important is that number of issues solved is about 14%. But that's not the real danger. The danger is before Devin, when there was ChatGPT and GPT-4 and all, you were at a 4% resolution rate. You're jumping now 3 times that. And you will jump even higher because technology progresses exponentially. So there will come a time when Devin will be able to take on standard software engineering tasks from humans, which means the Indian IT industry, all tasks which are automatable in software could be threatened. So there's a real fear here, right? So this is a valid fear. So people always ask me, Ajinkya, can AI take over? Are we at a place where we should just forget learning anymore? As Dr. Shah's video also said in the introduction, right? AI is doing this, AI is doing that. Why should we do anything? Why should we learn? Well, the reality, as always, is somewhere in the middle. AI can do a lot of things, but it can't do everything. And even when it does things, there's a lot of guidelines and guardrails it has to work under. Dr. Joshi talked about hallucinations and bias in her presentation. And one example of that was this chatbot that was created by Air Canada. So the story was that there was a passenger who booked tickets on Air Canada through their online portal, and he was talking to the chatbot. And unfortunately, he had just lost somebody. So Air Canada has a bereavement policy where you can book tickets for urgency because you've lost somebody close to you. And the chatbot told him that this bereavement travel policy had a refund policy, which was not true. So it actually hallucinated an answer because it wanted to sort of please the customer, or it got confused. But based on that response, the passenger actually booked the ticket. And then later he found out that there was no such a refund policy. So he took the case to court. And this was an example where Air Canada said, look, it's a chatbot, we're not liable. But the court said Air Canada is liable because it's your chatbot. You've trained it, it's answering questions on behalf of you. So you're legally liable. And then Air Canada was actually forced to pay a refund to compensate for the passenger, both for his loss and for the economic hurdles. So this is a reality check. You can't use AI indiscriminately without thinking through what it means to have accidents like this happen, right? So this is a travel chatbot. Think of it from a medical chatbot point of view. Suppose we all use WebMD and other sort of online resources sometimes to understand things. Suppose you have a chatbot which actually gives you advice on drug interactions, and a layman goes and asks, if I take this drug and this drug, is it okay? And the chatbot says, absolutely, go ahead. And there is actually dangerous interaction, and there is life-threatening illness because of that. Who's responsible? Is it the website, the hospital, the chatbot developer? So these are both legal and ethical questions. So AI is not yet ready to take over human beings. We're still not at that point yet. And this is one example of that. So hallucinations, bias, all of that plays into the fact that when you deploy AI technology, it's not so cut and dried. There are a lot of nuances that have to be taken care of, without which you can lead to catastrophes like this. The other part, which also was mentioned before, is the idea of copyright and IP. So when we use ChatGPT or any kind of large language model to create outputs, we think that this is fine, we can use this, but it's not fine. So there was a company called CopyLeaks, which used the outputs of GPT 3.5, and it found out something very, very startling, which was that 45.7% of the output from ChatGPT across different domains, the text generated, was actually identical to text on the internet and from training data, which means you're actually plagiarizing. You're copying an input to output, and you're using identical text from a copyrighted material potentially, right? That leads doors to a lot of legal hassles. So these are not good numbers. 45.7 is almost half of all generated text. Then you have 27 point something with some minor changes where it changed a word here or there. And then 46.5 paraphrase text, right? Where it's trying to do similar, but with the same kind of flow. Now, if you use this, for example, say for a legal document, you can be sued because you're directly using material which has not been given to you with permission to actually use that in your own product or in your own presentations. So using output from GPT indiscriminately is dangerous. And now what is being done, Microsoft, OpenAI, Google, they actually have a disclaimer when you use any of these large language models. They have a disclaimer saying this content is AI generated. Results are not guaranteed to be accurate. Please check with a human. So this was forced because they found out that there's a lot of potential for plagiarism, which opens the door to a lot of legal issues, apart from ethical issues. Right? Now, in this report, where it's given the link at the bottom of the slide, but in this report, you can also see that computer science has the maximum plagiarism, 100%. It copies things directly. Then physics, bio, and psychology. I couldn't find medicine directly, but with science and biology, you still have a high rate of being very identical out. So if you're using it for medical transcriptions, for example, or things like that, you're again going to open up the doors to a lot of issues. Okay. In fact, the New York Times has filed a lawsuit against OpenAI, the company that made GPT, because OpenAI used a lot of the news articles from the New York Times to train their model. And the New York Times considers this not fair use because of the fact that you're using data, you're not giving us acknowledgement or monetary benefits, and then you're using it to actually charge your customers at scale. So it's non-fair use of open source data on the net. And the case is ongoing. So we don't have a result yet, but there are multiple such lawsuits against OpenAI, against Microsoft, where artists, whether music artists or authors or script writers, have actually created class action suits against these companies, where they're claiming that either give us royalties or stop using our output because it's not fair use. And if any of these cases result in a positive outcome for these litigants, then there's a real danger that all these big companies, startups, will be forced to either pay out a big amount or shut down. So that's still to be decided. We haven't really seen the outcome, but copyright and IP is a huge issue. Okay. The other issue which people don't realize and which companies brush under the carpet a lot is the fact that generative AI especially is very, very power hungry. It's hugely power hungry. So if you look at some of the statistics from the research, right? One statistic is that if Google incorporates AI chatbots into every search that we do, then it's going to be using something like 29 billion kilowatt hours of energy per year. If you think of that number, it's a mind-boggling number. It's more than consumed by many countries together. So think about that. For something like a chat GPT to be used by people, you're using electricity, which is powering potentially a country for an entire year. That's not economically or environmentally feasible long term, right? One more dangerous statistic is that if you use chat GPT, which is now being used more and more, which responds to about 200 million requests per day from all over the world, right? It's consuming more than 500,000 kilowatt hours of electricity, which means 500,000 kilowatt hours of electricity. And an average US household consumes about 29 kilowatts per day, which means if you think about the math, it's 10,000 times more costly energy-wise to use chat GPT for a day compared to powering your whole house for a day. Do you really want to use that electricity for asking questions like, give me the best recipe for, tandoori biryani versus powering a house in a village for an entire day? Think of the repercussions, right? So even though companies don't say it explicitly, the energy demands of these kinds of models are huge. In fact, when OpenAI was training its models somewhere in the Midwest US, they found that the water consumption to cool the data center where OpenAI was training these models, I think on Microsoft clusters, it went up by 30%. So think of the water that's being used 30% more for those periods of those few months where you're training a large language model. Is that the best use of your scarce water sources? So there will be ethical concerns coming up as this thing scales. And there will be now companies focusing on what they call small language models, where they're trying to distill the information into something which is more feasible, both from the energy point of view and from the scalability point of view. Okay, so AI is not going to replace us anytime soon. There are a lot of hurdles which you have to overcome before AI becomes economically, ethically friendly and accurate enough to replace human beings. We're not there yet. Okay, so you've seen the sort of the hype of AI, you've seen the fear where AI comes in, you've seen the reality check where AI is not there yet. So how do we live with AI? What's the right balance? Okay. And one good example I found was how Vishwanathan Anand actually works with using AI for his chess. Right? I didn't know that he was actually an avid computer enthusiast. He actually uses computers and in the past chess programs and now increasingly ChatGPT in a way to increase his chess capability. So this was from a talk he gave at the Machine Learning Developer Summit in Bengaluru 2024, where he talked about how he actually leverages ChatGPT. And this is sort of a nice approach that could be used across different domains, different job profiles. So what he says is, if used wisely, then AI could actually help players save a lot of time. And how do they do that? Because when you use AI in the right way, You can actually learn new moves, understand your opponent's moves because it analyzes them, and you can be better in terms of anticipate. So he doesn't rely on AI blindly. He basically uses it as a assistant or as a conversationalist, where he asks it for an idea, a new chess move, for example, and then he uses his own brain, his own expertise, his own knowledge base to understand whether that new move makes sense long term, whether he can navigate through the new move, and how it's going to impact the play long term, right? So he's using the computer or the AI algorithm as a way to creatively understand what to do next. And so his last sentence is very, very foresightful. He says, all I need to do is keep asking the questions. The more questions I ask, the more I interact with it, the more I understand its output, the more I can then leverage its knowledge to become better and better. And over time, you suddenly realize that you're a completely different player. So this is something which I found very, very insightful coming from a non-computer science, non-engineering background, where he's using AI in the way that it actually should be used, which is as a tool, not as an overseer, not as something which is superior to human beings, but something which can actually work alongside human beings. Okay, and that's where we talk about the balance, right? So I talked about at the beginning of the slide, augmenting intelligence. Whose intelligence? We talk about augmenting human intelligence, our intelligence. So instead of thinking about AI versus humans, let's start thinking about AI and humans, right? Because that's the way we can move forward. When you start using AI as a way to make yourself better, make your knowledge stronger, that's one place where AI can actually help human beings, right? A good example of that would be in terms of co-pilots. We are talking about AI co-pilots rapidly now. They're coming in a lot of these different fields, from engineering to finance to medicine, where AI works alongside you, gives you guidance, gives you a lot of help in the right way to make intelligent decisions, but it doesn't oversee or overrule you, right? So one example of that could be where you, as a doctor, use an expert system to actually come up with different avenues of symptoms, but use your own judgment and your own expert insight to make the final choice, right? One more case I would want to highlight where you can use these co-pilots and where people are using it. So I come from a family of doctors, so I have great respect for doctors, the way they influence society. But there's one thing from a layman's point of view, I have to say, all of you have terrible handwriting, right? I mean, this includes my mother. I'm not making favorites here. I can't read what you put on receipts, right? So, and this is true of any patient you ask. I mean, what's written there? You take a magnifying glass and then, right? So one place where you could actually have AI help out even today is to go from voice to text. So you have these large language models, you have text transcription. So instead of writing on a piece of paper, if you could actually voice out your diagnosis and your prescription, and then the AI model actually converts that to text and prints it out, and then you just review it once and print for the patient, it would be much, much more useful because it's safer. You can review. There's no handwriting problem because it's standardized text now. It's on document. And think of the medical legal issues, right? So patient goes, takes 50 milligrams instead of 5, comes back with symptoms. So you can take away all of that by potentially using this at scale. Now, where this has already been done in many US hospitals. You've got many medical subscriptions now, companies which do that. But what today's models do is they allow you to do that at scale. So even a doctor who has a small clinic somewhere can use these open source AI models, convert voice to text, and then use that to give patients the output. Because that's one thing we can think of. That's one way of doing that. And the other place is boosting creativity in general. So creativity for human beings, artists or others, AI could boost that. And the last one could be personalized learning. This is something which could be very, very revolutionary. Now think about, for example, a new MBBS doctor in some village somewhere where they're trying to now look at patients. If you could have an AI model which has distilled the experience of all the senior doctors in a particular field, like a physician, for example, and that AI model works alongside this new doctor, where if a patient comes with new symptoms, it can say, look, this in this way, this is a very low probability diagnosis, but think about this symptom and this disease. That doctor starts thinking, oh, maybe not, but potentially. And that sort of opens the door to training that doctor automatically without a senior doctor being present. So personalized learning, whether it's in the medical field, in the engineering field, in the sort of finance field, this is going to be something that will boost human creativity and boost human efficiency longer term. So that's where the balance comes. Using AI in a way that becomes part of us rather than us versus them. And so the last two slides, now the way forward. How do you achieve this balance? So this was an image created by DALI, which is a generative AI image creation. It shows a robotic Pied Piper of Hamlet, right? So where the Pied Piper is leading its minions across either destruction or not. And so you can look at it in two different ways. One way is that AI is the Pied Piper. So you have all these different, big companies, Google, OpenAI, and so on, with their large language models and their cloud computing as drones. And they're leading you as doctors, by their diagnosis, where you don't have a say or you blindly trust them. That's one model of the future. And the second model is where you as doctors are in control, where you're using AI as tools, as assistants, but you are the ones who finally make the decision. And they work for you to augment your intelligence and your capabilities. So which of these futures will come true is based on what choice you will make in the future. So choose wisely. And that's also the end of my presentation. So thank you. I guess we're open for questions now.
Thank you, Ajinkya, and thank you, Aruna. Now I'm not going to speak as an executive director, but as a very proud family member. So allow my indulgence. Aruna Joshi is a cousin of my husband, Yashwant, and I've seen her when we got married, as a brilliant IIT student. And I feel so proud where she has reached. So Aruna, it's fantastic the way you gave a lecture. And second, my son, Ajinkya. As a mother, you feel so proud when your son delivers AI so beautifully. And Ajinkya when he was doing his MS in Carnegie Mellon, they had a project in NASA where he worked there, and they had this Atacama Desert report thing, and he got a prize for that. And he could have stayed in US, he could have done his things there, but he always wanted to come back to India. So instead of doing his MS robotics, which would have a less chance in India, he switched his PhD to control systems, because he said that will have some future in India, and I will not be tempted to go back to USA. So I'm glad that he did that, and he's back in India, and I'm very, very proud of him. So as a parent and as a sister-in-law, I'm very proud these two wonderful speakers have been part of AI webinar. This is not nepotism. That's why I didn't start in the beginning, because they both have such wonderful credentials that I would have called them anyway, and they are invited on various platforms. The second comment I wanted to make, what Ajinkya said about personalized learning. And I would like to give my experience, which way back in 1989-90, I did a fellowship in Harvard University at Mass General Hospital in the medical informatics department. Yashwan had got a fellowship that time, and we all went together. And there they had a system called DXplain, which was an expert diagnostic system. And I worked as a visiting professor to work on the pediatric database. And it is exactly what Ajinkya said, that you put in a symptom complex and it comes out with a differential diagnosis. And as you keep putting more and more stuff and more investigations, it comes with a final only 2 or 3 diagnoses, which can, as you said, help a very junior doctor who's working in the periphery. However, I think some things are beyond their times, and that is why this DXplain didn't flourish. But this is one expert system which had a lot of potential. A second thing of personalized learning, I also had a chance to visit Bethesda Naval Center. And that time they were doing a lot of research on simulations. And one day was a fantastic experience into future. They had a simulation where they had a body, a cadaver, which could be dissected n number of times by a doctor. And just imagine that instead of having a formalin smelling body, you could dissect layer by layer and learn. And what was the applied thing to this? A surgeon could go to, say, an appendixectomy and practice his ways of doing appendixectomy on that simulation, so that he can become much more proficient. And if he did not have a chance to work on 100 patients, he could make himself a personalized learning. I also saw a simulation where they used to train doctors, army doctors, surgeons who are going into the battlefield, where they had to deal with various traumas which they had never seen in their life. And this simulation was surrounded by bomb blasts, noises, patients crying and screaming with pain, and you had to learn how to do the trauma surgery and how to operate in that environment. It was fascinating, and this was in 89-90, and this was something which I learned. Thank you, Samir. You can now take over.
Thank you, madam, for your personalized experience related to the how the early AI is there in the different part of the world. And this is the international forum. That's why we had kept this talk today regarding the artificial intelligence, how it works across the world, not only the India and the surroundings, because we are too far away from that type of the speciality what you are talking till now also. But now the AI technology is flooded the market, and what the CJR of say that it will be the increasing by 48% the market from 2024 to the to 2029. So it's having a so high opportunity to improve the AI related technology, and that will be the now really a continuously becoming the future of the AI. And in and every each and every field, what we can say, not only in the medical field, but the just you got up with the thing and the AI start the working for you. Okay, whether what you have to do for yourself for the whole day and the what will be your whole day activity. So that type of the AI is now going to come. Definitely. So now I before because time is too much going very fast, and we are already passing the 1 hour and 20 minutes. So now we have to wrap up the session. Before that, we ask the audience to having any question, they can write the things in the chat box. Before that, I having a one or two question what I received from the chat box and the one comment also. So that let's read that, and then we can discuss further. One question came: how true is the statement in a cartoon that's shown by Dr. Aruna Joshi that increase the artificial intelligence may lead to decrease in the real intelligence? Can any both of the faculty can comment one by one on this talk? Start with Dr. Aruna, ma'am.
Yeah. So I think the question is, are we going to get dumber? So I always go back to the answer, so before the cars were invented, right, people were trying to come up with more and more efficient ways to clear all the horse manure, from the streets and whatnot. But then the cars were actually invented, which removed the need to clear all the manure. So basically, in my mind, I think humans are always going to adapt. Humans are so creative that even if one kind of job goes away, another kind of job will come up. Manufacturing, earlier people used to use their hands to build a lot of things, then they built the machines. So the new type of education on how to actually use the machines came up. So in my mind, humans are so creative that they're always going to be able to find a way to combat this artificial intelligence.
So it really depends on whether you want to dump or you want to come out. That's the things the answer will be. Dr. Ajikya, your comment, please.
You need to unmute.
Yeah, I think my answer mirrors what Dr. Joshi said. It depends, frankly. I mean, in certain cases, jobs and skills will become dumber because they will become obsolete. In certain other cases, new jobs and skills will be created, which will make humans smart. I mean, one example, again from the past, was when we had lifts and elevators. We used to have these liftmen in the elevators because people were scared of going up and down so many stories, and lifts were not safe that time. So you always had a liftman. That was a job that was created. As lifts became safer, as things became larger, the liftman was eliminated, right? So that's one job profile which was out, but it was replaced by other things. So I think in general, it depends how you choose to use the AI. If you choose to be dependent on it completely, you will become dumb. I mean, it's true of us with telephones, right? Now, with everything in databases in your mobile phone, I used to remember about 10 numbers in the olden days when there was a touch dial phone, right? Because you used to have to just remember numbers of your friends, family, and so on. Nowadays, you remember maybe one or two emergency numbers. You've got 100 others which are not in your memory at all. So have we become dumber? No, I agree with what Dr. Joshi said. We've adapted. You don't need to remember 100 numbers anymore. So that part of your cognition has become useful for something else now. You remember some other things maybe. So I would say humans will not become dumber. They'll adapt, but it's up to you to choose what you adapt to.
So it's a theory of the Darwin, what we usually say. It's a theory of the existence, and what we really require that we have to learn and unlearn. And that's a part and parcel of our daily life also. And this the technology teaching us how we want to become smarter or the remaining as a local the previous era only, or we have to come forward with running the life with the new era. That's definitely
Survival of
it
the
is.
fittest.
Absolutely. One more question that come by Dr. Ushma Sadachar. Does the artificial intelligence can diagnose the psychosomatic disease or disorder? How can it deal with the interpersonal problem where they require more human approach?
This is going to be a very difficult thing because it will require such a huge database because the garbage in and garbage out. So unless the model is very robust and we have put enough data inside, the results may be quite astounding. Yeah, the board experts can speak. Yes, I think Aruna.
I requiring both the speaker don't unmute mute yourself because
Yeah,
I
keep
have
yourself
to
unmute. Yeah.
unmute only.
Okay. Yeah. Yeah, in my mind, even my sister is a doctor, my brother-in-law is a doctor, and we have lots of doctors in my extended family as well. In my mind, I don't think AI can replace the doctors completely. And as Ajinkya was saying, AI will be able to help doctors become more efficient, but I don't think it can completely replace the doctors.
I certainly hope not.
Yeah, there are so many intricacies, involved with psychosomatic diseases and interpersonal problems. So AI can only talk about what it has already been trained on. And if it comes across a situation that it has not been trained on, it's going to hallucinate. So I would definitely recommend if people actually go and talk to a psychiatrist rather than just depend on AI. It's good for trying to figure out, for some small things, but for major problems, go to the doctor.
We already have problems of Google search and Google doctors and patients
Exactly.
coming to us with that Google knowledge, which is so tough to handle.
Yeah.
Yeah, I think it's dangerous if you start using AI for psychosomatic, any kind of psychiatric or interpersonal problems, because it can lead to a lot of issues. For example, there was a case of where they tried to use a chatbot for patients who were in depression. And what happened was, as the conversation progressed, it came to a point where the patient said, I'm so sad, I don't know what to do. And the chatbot answered, then maybe it's better you end your life. It's an optimization problem for it, right? So that's one solution. It's not the right solution, but that's a dangerous trend. So I would definitely not recommend using AI anywhere where there's human fragility involved, human emotions involved, because as Dr. Joshi said, as Dr. Swati Bhave said, very nuanced. It's not something we can teach a machine. I don't think we can ever teach a machine that. And that's why we should never try to have machines go in that area. I mean, a similar question I get asked, when will machines get conscious, or when will they actually have common sense? And my personal belief, looking at all this, is you can't become intelligent unless you are alive. And the reason I say that is because being alive or not being dead is a very, very strong reward function, which means that when you evolve, the reason all of us are intelligent is because fundamentally, not just us, cats, dogs, most organisms, the reason we become intelligent, the driving force is you don't want to die. And so nature has evolved you in a way that you get features, you get intelligence, you don't want to die. Machines don't care about dying and living. And I know there are computer scientists who, from my generation and beyond, who think you can actually simulate dying and living as a cost function inside the optimization of the models. I don't believe that's true, because there is something fundamental about consciousness which is linked to biology, which I don't think as a computer scientist you can replicate with bits and bytes in digital neurons. That's a personal opinion, and I'm sure there'll be others who will contradict that. But I personally believe to become conscious, to become intelligence, you want to have to not die. And you can't do that with a machine at today's stage.
Anybody else has any comments or last 1 or 2 lines by our chairman, Great Anis? Then Samir, you can wrap it up. Dr. Great Anis, are you there? Chairman of our AACCI International Forum. Yes, unmute please, Dr. Great Anis.
Hi, yes, there it is. Okay, well, fascinating, absolutely beyond fascinating. I want to thank both Dr. Joshi and Dr. Bahab. It's absolutely amazing. First, I want to give condolences to your colleague who passed on. Sounds like a wonderful person who has influenced and countless people into this century with their wonderful attitude. I love the issue of how well she passed on with such a wonderful attitude. I come from a Western European, Dutch, Scotch background where we try to teach the same thing to our kids, something better going on after us. I was just on vacation with the family up by Lake Michigan, and a lot of people who passed on, they have a little sign that says, "Gone fishing," or "Gone boating," or something, or this positive attitude that we have. So I just love that. It reminds me when I was a boy in the 50s, reading a wonderful story by a wonderful British author named Aldous Huxley, who wrote a beautiful book called Brave New World about a genetically engineered society. He gave kind of a dystopic negative view for the future of this society. I appreciate our speakers giving a more positive view of what's going to happen. It's not going to affect me or those of my age group, but our kids, grandkids, great-grandkids, where is this going to go? I appreciate your positive attitude. Time will tell. My view from my generation would be, who is going to control this as it gets stronger and better and better? And people have often been wrong in various predictions. Who will control it? And from a simple question, what if you can't shut it down? And a good example will be the U.S. elections right now. We have two different sides. Without getting into a diatribe on my views, if one side wins in November, this country and maybe the world goes down one direction. If the other side wins, look out. We don't know what's going to happen. So I think from Aldous Huxley point of view, what will happen, time will tell. But absolutely fascinating. We appreciate the discussion, and nice to see another family member of Dr. Swati Bahab. As that's fun to see. She and I just worked on a book on pediatric lung problems that will be coming out next year. And we actually talked about AI in one of the chapters, not the one that Dr. Swati did, but some other ones. And the conclusion was, we don't know what's going to happen and the influence that AI will have on computer testing and diagnostic skills. And so we concluded, you'll have to read the third edition, the next edition in several years to see if we've learned anything. But it is indeed, as Aldous Huxley said, it's a brave new world, and let's see what happens. Thank you. It was just absolutely fascinating.
Thank you, Don. Samir, please go ahead.
Right. So, dear friends, now it's time to close our talk related with the artificial intelligence. Our intelligence is definitely avoiding us to continue long discussion, because all the things has to come at the end with a related that the human intelligence is always very highly intelligent than the any artificial intelligence. It will be the augmenting our human intelligence. It is not the just artificial intelligence is, and everything that we have to keep under the arm of the ethical consideration, that we have to keep in the mind before utilizing the artificial intelligence in any field, not only healthcare but the everywhere. At the same time, regular updating ourselves to the technology is equally important to utilize the any technology in a right way, without fearing or without making more and more bias of our own idea. what Dr. Aruna Joshi has told me us, that the bias are in our mind, and that we have to clarify with the regular updating ourselves. And if we do able to do, ultimately it will reduce our hallucination to utilize the artificial intelligence, what Dr. Ajikya Bhave has told me, and that will become ultimately a balanced approach of the any technology. And that is the our crux of today's talk by the our two eminent speaker and the PhD persons of the artificial intelligence. Thanks a lot to the both of them for the enlightening us for the excellent presentation. And my sincere thanks to each and every delegate who has remained till end to understand what the artificial intelligence is. Thanks a lot once again, and we will definitely meet again in next month with the same second Saturday of the month. Thank you.
I request the Bhave family members to please wait. The rest can thanks for attending. You can log out. Thank you.